accredited by All India Council of Technical Education (AICTE) and accredited by NAC with CGPA 3.20, 3.21. All UG programs are accredited by National Board of Accreditation. Department of Mathematics and Humanities, known for its excellence in teaching and research. All the faculty of Department of Mathematics and Humanities are committed to quality through teaching and research with intellectual culture that bridges mathematics with engineering applications and provide holistic engineering graduates prepared for life service, life purpose, service, and leadership. Apart from teaching, faculty of Department of Mathematics actively engaged in research and guiding the students of BTech and MTech in their project works. As a consequence, all the faculty of Mathematics and Humanities publishing their research papers in reputed national and international journals and doing their collaboration work with other departments, other institutions, and universities. On this fruitful occasion, I would like to thank all the resource persons, Professor Y.N.Reddy sir from NIT Warangal, Professor Jyoti Mishra madam, Professor Mini Rani madam, Professor Dhananjay Rao sir, Professor Lakshminarayana sir for accepting our invitation in spite of their busy schedule and ready to give their valuable inputs to our participants. My heartful thanks to Professor Y.N.Reddy sir, NIT Warangal. Sir, you as a resource person in this FDP added lot of value. I proudly say I am student of Professor Y.N.Reddy sir during my MSc Applied Mathematics study in the year 96 and 98. Not only PG student, I am heartfully saying I am the Professor Y.N.Reddy sir, my project guide in my dissertation. Title is Numerical Asymptotic Method for Singular Perturbation Problems. I am very fortunate. I am the student of Professor Y.N.Reddy sir in project work. Not only me, few of the faculty of my department did their MS Applied Mathematics in NIT Warangal. Few of the students of my department are Y.N.Reddy sir. Not only in this institute, maybe more number of participants of this FDP are students to eminent Professor Y.N.Reddy sir. Sir, with your guidance, we introduced Kakatiya Institute of Technology and Science, introduced minors in mathematics. So if a student want to learn additional learning in mathematics, we introduced a minor in mathematics, especially numerical methods. We made numerical methods as a compulsory subject for minor. I am very much thankful to Professor Y.N.Reddy sir for accepting our invitation as a resource person in this faculty development program. Sir, Miku Padabi Vandanamu sir, as a student, Miku Padabi Vandanamu sir. Now, I thank my colleague, Professor Madhukar Reddy sir, Professor Madhukar Reddy sir, Head Department of Physical Sciences, who for continuous support towards Department of Mathematics and Humanities. I would like to thank HOD, CSC, Professor Shankar sir for his technical support. I thank all the faculty of English, especially Professor Abdullah Devi madam for her continuous support in this faculty development program. My special thanks to Kiran, programmer, for making arrangement of YouTube live session to this faculty development program. One and all, I thank all the participants of this FDP. Kindly listen all the sessions of eminent speakers and make use of this FDP as a platform for your future work. Thank you, one and all. I request Dr. Anand over to you.
Thank you, sir, for with your few words. We enlightened about the program. I consider great honor to welcome our beloved principal, Dr. K.Reddy, sir, chairman of the program. But sir will join after some time. I am delighted to invite Professor Y.N.Reddy, NIT Warangal. I request my colleague, Dr.Y.N.Reddy, please give brief introduction about today's speaker, Professor Y.N.Reddy.
Respected sirs and madams, all of you very good morning. This is all of you very good morning. Thank you, sir, Y.N.Reddy sir, for accepting. Thank you, sir, Y.N.Reddy sir, for accepting our invitation and taking out your previous time to bless us with your esteemed. It is my great privilege to introduce today's speaker and also my guru, Dr. Y.N.Reddy sir. Everyone dream is to have a degree from IITs. That dream is fulfilled by Professor with his PhD from IIT Kanpur in 1980s. Presently, Dr. Y.N.Reddy sir is working as a professor in the Department of Mathematics, NIT Warangal. He has 30 years of experience in teaching and research. So far, he published more than 180 research papers in reputed international journals. He guided 12 PhD students, and his research area is singular perturbation problems and numerical methods. He also received the Best Teacher Award from NIT Warangal. I welcome Professor Y.N.Reddy sir to deliver the lecture of the session. Thank you, one and all.
Thank you, Reddy sir. A small, sir, Professor Y.N.Reddy sir, I am audible to you, sir. Sir, a small change. I'm audible, sir.
Okay.
A small change in program, sir.
No problem.
Principal sir want to speak just now, sir joined. Before your speech, Principal sir take out the session for a few minutes, sir. Thank you for waiting valuable time. Sir. Thank you, sir. I request our beloved principal, sir, K.Reddy sir, chairman of the program. Please carry on, sir. Session, sir. Good morning, sir. Hello. So, I consider great honor to welcome our Sir, good morning.
Dr. Anand.
Good morning, sir.
Dr. Anand.
You are audible to you, sir?
Dr. Anand, can I speak for a moment?
Yes, sir. Yes, sir. Carry on, sir, please.
Yeah. Thank you very much, Dr. Anand and Professor Y.N.Reddy, sir. Good morning. I'm extremely sorry I joined late. I was in another meeting, inaugural session of FDP, Faculty Development Program by Department of Civil Engineering. I got a little late. I really seek excuses from each one of you. Thank you very much. Respected HOD and then coordinators of this workshop, Anand Kumar and his team, eminent speakers of this faculty development program, and more importantly, our beloved Dr. Y.N.Reddy sir, all the other speakers, and the faculty colleagues from Department of Mathematics and Humanities at QuitsW, and also all the participants. Warm welcome to all of you. This institution, Kakatiya Institute of Technology and Science, Warangal, started working in 1980. We are now 40 years old institution, and all these years we have been greatly nurtured by two institutions. The one is Kakatiya University, to which we got affiliated for the last 40 years. Then REC and present NIT Warangal. When we started functioning in 1980, the professors from NIT Warangal, the then REC Warangal, they really helped us a lot. And whatever position we are in, it's just the great blessings from these two great institutions, Kakatiya University and NIT Warangal. So with this, I really thank the organizers. Dr. Anand, you did a great job, selecting faculty development program on numerical methods. And very important point here is almost all the faculty members of this mathematics and humanities department, somehow they are the students of Professor Y.N.Reddy sir. And majority of the faculty members, they did their either post-graduation or PhD from NIT Warangal. So that's how we got closely related to NIT Warangal. And I take this opportunity to thank all the valuable speakers. Dr. Y.N.Reddy sir, so kind of you, sir. You are sparing your valuable time, because every faculty member, they really value you and other faculty members, because being direct teacher to many of the students. And here, if you can see HOD Shivashankar, Anand, all the faculty members are your direct students. Thank you very much, sir, for giving helping hand. This is the first faculty development program, this mathematics, and they are conducting in the Department of Mathematics in the recent times. So let us hope for the best, sir. Dr. Lakshmanana Garu, VJIT Hyderabad, thank you so much for your great help in helping the academia, mathematics related academia. Jyoti Mishra, GGITS Jabalpur, thank you very much, ma'am, for your kind acceptance. Dr. Mini Rani from NMMS University, Mumbai, thank you so much, ma'am. I'm really thankful to you. And then finally, Dhananjay from BITS Goa, another friend, faculty colleague, for taking part in this faculty development program. Fraternity of Kids Warangal, my management Captain Lakshmikanta Rao Garu, many of you might be knowing, he is a member of Parliament Rajya Sabha. He is also ex-captain. And another management member, Narayan Reddy Garu, they felt very happy when I told about the eminent speakers who are helping the participants of this faculty development program. Thank you very much. And I wish good luck to the organizers. Anand, I wish you all the best. Shivashankar, you are doing great job nurturing the faculty member at Department of Mathematics and Humanities. Please continue your hard work. You have all the blessings of the eminent speakers with whom Anand and you are in contact with. So please maintain these relations. We can take help from all these eminent professors in near future also. I wish all the best to all the participants. Happy learning. Thank you very much. Bye.
Thank you, sir. Thank you for your valuable suggestions, sir. I need your blessings. Thank you very much, sir.
Thank you, sir, for your kind words. And with your permission, we are starting the session for the today's speaker, Professor Y.N.Reddy Garu. is ready with us. So kindly we take the permission from you, sir, to start the session.
Thank you, Anand. Y.N.Reddy sir, good morning and welcome, sir.
Good morning. Good morning, sir. Yeah.
That's right, sir.
Thank you, sir.
Am I audible clearly?
Yes, sir. Yes, sir.
Thank you, Professor Y.N.Reddy sir, for accepting of taking out your precious time to place with us and your esteemed present here. So with your permission, session to you, sir. Can we hand out to you, sir? Thank you, sir. So we are eagerly waiting for your session, and all the 16 participants are waiting for your speech. We are welcoming you, sir, on behalf of KidsW, and thank you, sir.
Especially Professor Ashok Reddy. Separately, unless his encouragement is there, this program would not have been possible. And as he mentioned, Kids Warangal and MSc Warangal.
Sir, excuse me, sir. Excuse me, sir. Can you present your video also, sir?
Yeah, video also.
Ikkada ravatలేదు, sir. Maku ravatలేదు, sir.
Special thanks to Professor Ashok Reddy because his encouragement to the mathematics. And sir, the bondage between NIT Warangal and Kids Warangal is for 40 years, as you said.
Yes, sir.
And we know exchanging the cooperations both ways. Now, when Anand called me and told that, sir, we are conducting that bondage and the understanding of cooperation, I could not say no. And in fact, happy. The title which you see interdisciplinary. Because the title really, no, I don't know how he caught that title. Mathematical modeling comes from the so-called engineers. I use the word so-called engineers sometimes because we also form a mathematical modeling. When they form the mathematical modeling, it is because of the real life problems. But the problem ends there for them. I'm sorry for the engineers because they really end up there. They are wonderfully creating a problem called a mathematical equation or a formulation or a model. Then the job of mathematics person comes there. So that's exactly the two titles. Mathematical modeling is done by the engineers, and then they seek or request or help or ask, whatever the word is. Unless we cooperate, you are held up. And this is exactly what we want, a real life interdisciplinary approach in thinking itself. So as a mathematician, we are here to help. When you formulate a model, maybe we together formulate a model, the ultimate job is to solve that. To solve, there are so many times you will have methods. Some methods only become popular for some reasons. Let us not quarrel, let us not use the word luck. Let us not use any word or luck or fate. Some methods become popular because there are scientific reasons for that. The method must be user-friendly. Method must be simpler. That's what the whole world wants. An engineer like Ashok Reddy can't spend more time. See, it's like a patient. Patient need not know the ingredients of the tablet, but the mathematician knows ingredients of the tablet. Sometimes if you tell the ingredients, the fellow will be afraid. So what do you call it? You call it as a capsule. You prepare a capsule and tell him that you eat it. The engineers eat it comfortably and gets cured. So mathematician should know ingredients of the method. User need not know, should not know sometimes better. Because, for example, I'll tell you one simple example. In the BTech level, first year itself, we teach Range-Kutta method. We call it a fourth order method. I'm sure we don't teach why it is fourth order, how it is fourth order. But it has become a very popular, any BTech first year fellow can use it. So it must be like user friendly. Actually, if you really go for the real meaning of finding the why it is fourth order, I'm sure most of the faculty cannot do it. That is so ingredients are so strong. It is to prove it is a fourth order method, they need about 4 or 5 pages. But the wonderful is engineers don't want that. Sir, I am comfortable, sir. But it must be user friendly and simpler. See, don't complicate things because already they are tired of, in the formulation itself, they lose many things from real life. They cut off this, they cut off that, they approximate that, then they come up with some beautiful equation and say, sir, I'm helpless. Don't have to use the word sir, but at least Mr. Colleague Shivashankar, solve this. Shivashankar should be in a position to solve it and explain the solution, analyze the solution. That's exactly the interdisciplinary. The spirit of engineering college is meant for that. Not to keep the mathematics departments isolated, untouchability, or so-called stepmother treatment. Use them. They are the real resources because when you are held up, better give the job to like call a subroutine program in your main program. You have a main agenda for your civil engineering. You don't have to waste for solving one simple equation. Ask the Shivashankar or Anand to solve it and give it. The job is that much only. If they want to understand, better. So my idea is that somehow to help the researchers or think what are the methods which really are being used. So some methods I will not explain the ingredients. No, direct I will tell this is the method, you use it. You should have belief. No, you should have confidence on, as we have confidence on doctors. If you doubt the doctor, you will die. Forget about doctor. So if you doubt the mathematician, so you like it. Sometimes we will explain. If you can understand, you will explain. Like Corona, we are trying to explain. See, but beyond that, you need not understand why it is, how it is. No, it is too much. Sometimes better not to think about that. So use the tablet as it is, capsule, what you call it as. So these are the wonderful methods. We have been using it, but somehow have become very popular. Why it is popular, I will explain. My topic is connecting both, mathematical modeling and the.
Sir, excuse me, sir.
I'm going to PPT.
Yes, sir.
Methods, the very popular concept in mathematics, and knowingly or unknowingly people use it. When they have to use it, they have to use it cleverly, clearly, and so that they don't get into trouble.
Sir, excuse me, sir.
Yeah.
Sir, excuse me, sir.
Yeah.
Your PPT is not visible, sir. Can you,
Yeah.
sir? Can you present your PPT, sir?
Yeah, just.
Okay, sir. Thank you, sir.
Yeah. What's in there? You got it?
Just presenting, sir. Waiting for.
Yeah.
Y&Reddy is presenting.
It takes time. I'm in Hyderabad.
Thank you, sir. Thank you. Yeah, it's visible, sir. Please carry on.
Yeah. So the title is Shooting Methods. To solve the most of the mathematical problems, the modeling is not in our control. They model from the real life problems. They land up with some equation, maybe a differential equation, maybe a differential equation or partial differential equation, some problem. And I will explain the difference between the equation and problem. So my title is Shooting Methods. It is known to most of you. Maybe for some people it is the repetition. If they are already using it, please be comfortable. I will add the two aspects of the latest developments of the shooting methods. The main idea of this shooting methods is the word, of course, shooting came from the real dictionary meaning. And why and how, let us not quarrel. It has come from that only, shooting from a gun. It's like game theory or a sports activity. So there is no difference. It's actually the dictionary meaning only. What we do in the name of shooting methods is the simple concept. So we have something called, I will use words now, later on I will explain. The concept is to convert the boundary value problem into integral value problem. Why and how, we'll explain. So the main purpose of the shooting method, what the concept of the shooting method is to convert boundary value problem into integral problem. And I will explain, justify why, how, etc., etc. Okay. So the simple theme is nothing but converting boundary value problem into integral value problems, specifically in differential equations. Let me recapitulate this because dear all, this PPT will be given to all by sharing. There is no need to panic, and everything will be known to you. Don't have to even think about it. To make my lecture self-contained, so that even if there is a non-mathematician should understand what I'm talking. Otherwise, it will be going in the air. So I'm just using certain definitions, maybe for the benefit of the mathematicians, what we understand and accept in the definitions. See, generally we come across with the differential equation. Any equation, we need to solve it. The meaning of solution is an understanding that Duke's definition is, it is nothing but a relation between the dependent variable and independent variable. In engineering time, it's called input and output. A relation between the input and output is called the solution. There could be many solutions for a given problem. Because individual thinking, it is a relation between the two functions. Anybody can give any relation, and sometimes it satisfies the equation. Anything which satisfies the equation is called a solution. But we call it as a general solution. The next definition is general solution. It is more than the solution. It is a master solution. General solution is defined as, it is a solution, but it contains arbitrary constants equal to the order of equation. If you have a fourth order equation, there must be 4 arbitrary constants. By hook or crook, you have to involve 4 arbitrary constants. Anything less than that, more than equation. So I understand for a given differential equation, there is a general solution which contains the arbitrary constants. This is what we call equation. We teach for BTech first year students in the equations are different from the problems. problem, it is a real definition. Again, dictionary meaning. Problem is samasya. Oh, the samasya. And that problem is, you have solved it. You got the differential equation. You have got to solve the general solution. Now, what is the problem now? The problem is to remove the arbitrary constants. How do you remove these arbitrary constants? How many are there? Equal to the order of equation. These arbitrary constants, why did you create it? Because you want to make it as a general solution. So everything is beyond your imagination. So as a mathematician, we want to do it, we jump into problem. If we were having the equation, we could solve it, and we made it a general solution. We are now ending with the problem. The problem is to eliminate these arbitrary constants. How many arbitrary constants are there is equal to the order of equation. So now we need to ask from the engineer, what he called it as, from the engineer, sir, give me conditions so that I can eliminate these arbitrary constants. Then he will question me, how many conditions you want? Let us not talk about anything. He doesn't know anything. He says, well, how many conditions you want? He will give the conditions. How many you want? It is number is equal to the order of the equation. So to remove the arbitrary constants, why did we introduce arbitrary constants? Because we want to make it as a general solution. Because a solution cannot be open acceptable to all. General solution is acceptable to all. So general solution contains arbitrary constants. Arbitrary constants are to be removed. Then you badly need the number of conditions. The number of required conditions are equal to the order of equation. Now the question comes, how he will give the conditions? Because it is the giver and taker problem. You only ask for the condition. Whatever the condition he has, he will give. He may have his own way of giving conditions. There's a difference between the problem modeling and the numerical approach. Suppose for all the conditions, how many conditions are required? That already known to us, fixed. That is the order of the equation, because arbitrary constants are fixed. Number of arbitrary constants are equal to the order, and the required conditions are given. Say, for example, it is second order. You badly need two conditions. You ask him, he will give the two conditions. How you will give? Based on that, the definitions will come into picture. If the required conditions are given at one point, at the starting point, call it as initial point. Take an equation, y double dash is the second order equation. Right side, you put everything in this side, and this is a beautiful popular structure of second order equation. And two conditions are given. What are the conditions? At A, that is called starting point. The velocity and acceleration, both are given, or displacement and velocity, both are given for a given vehicle. The information he has is that, sir, I have a velocity and acceleration. So this is what called y and y dash, or displacement and velocity, both are given to us. At the starting point, if they are given, that is called insularly problem. There is no problem in solving this beautiful structure, because it is a second order equation, two conditions are given, and BTech first year fellow solves. We teach so comfortably, and he can solve RK methods or any method for that matter. The best method what we teach them is, and probably we stop at that place called the Rangekutta, fourth order or whatever the better method. And in fact, you can also write as so-called Mathematica, MATLAB or solvers. We have initial value problem solvers, IVP solvers, these are packages. The biggest advantage of this problem, why this is enough for them. If you know this much, you can really conquer the world. Bonus, in fact. The reason why this much is enough is the advantage of this method is it doesn't force you to choose the step size. Even if you choose the step size, it has to be fixed by 3 times. And now let us start. You have converted or written as insular problem. Solve it. Since it is insular problem, BTech solves it in seconds by RK method or any method for that matter. So let us not quarrel that insular problem can be solved easiest way. Once it is, because we have avoided the matrix problems. Once the matrix problem has gone, the job is simpler and simpler and easy. That is called y of x. Any solution is called y of x, relation between x and y. Now let me why it has come, how it has come, because of whom it has come, because of the m it has come. So I just write deliberately y x comma m to indicate this solution is because of the great friend m. If m is not there, I would not have solved it. So there is a justification why I write m. So no mathematical unnecessary inference here. Permission is granted. Okay, so the y x is because of m. If m is not there, I would not have solved it. So there is a genuine justification of writing the y x comma m. So, but how do you know that this is a correct solution? Some m you are taken, you got the solution. Cannot be guaranteed that this is correct answer. How do you say this is correct answer? Now, if you have y of x comma m, what was the given condition? Y of p is given. That condition has to be satisfied. So we have to satisfy the missing boundary condition which is given to us. So what we do is nothing but let us evaluate the solution which is just now obtained because of m, and evaluate at p. you know what it should be. It has to be satisfying the unused boundary condition. It was not used. Instead of using y of b, I created a y of y dash a and solved the problem. To check whether my m was right or wrong, I have this solution at b, what is the value of that? Is it equal to beta? If it is beta, beautiful. That is exactly what you guessed perfectly. But many times it is not possible. Remember, beta is a number. Y at a point at x is equal to some b, it is going to be a number. Now you are comparing two numbers. When you are comparing two numbers, there are three options available. First option is y of b is less than beta. Second option is y of b, m I am not mentioning every time because it is because of m. So it's like m is equal to beta, then my guess was correct. What happens? Third option would be greater. So these are the only three possibilities which can happen. For my m, with the help of m, I solve it, I got a solution, evaluated p, and I find a comparison. If it could be beta, lucky, that's case 2. If it is not beta, then what can happen? As it is less than or greater than. This is called under beta or greater than the beta. Your choice of m is wrong. And we concluded that m should be chosen properly such that case 2 only happens. Case 3, case 1 should not happen. So for what value of m we get this? What should be the m? How do you choose the m to land in case 2, not in case 1? The idea is very clear. So there is a reason, the justification or question, how do you choose the m? Now my m must be such that y of b comma m should be equal to beta, not less, not more. Now let us write it mathematically. Or find the value of m such that, so when I say y of b comma m is equal to beta, I bring one side, so I write it deliberately as a one side, y of b comma m minus beta is equal to 0. So we want m such that y of b minus that is equal to, which equal to means is difference going to be 0. So deliberately, this is a beautiful way of writing it. Y of b comma m is minus beta is equal to 0. Oh, that means I have to choose the m such that this structure must be 0. Now, this whole structure, now I just, for your information, I just want your permission to denote. Let us denote it as, because after some slides I need this. Instead of all the time calling y of b comma m minus beta, I denote it as phi of m. Phi of m is equal to the difference between these two, beta and my function value. So y of b comma m minus beta is equal to 0. That is what we call it. This is the, I'm just denoting by phi of m. Moment you denote it by phi of m, for a mathematical, see, sometimes, for our own, what you call it, for satisfaction, I look at what would be the dash. What do you mean dash? Derivative with respect to m, because there is phi is a function of m only I have deliberately mentioned here. So moment you say phi dash m, it is a derivative with respect. But this side, why? Now as a mathematician, I am too much mathematician. Function has two structures, so it is a differentiation. So there are two structures. So I put it as a dou by dou by m. So the partial derivative with respect to m. What about beta? Is a dead body. Differentiation with respect to anybody is 0. So the phi dash m is this much. So these two target was this only. How do you find this m such that this quantity is 0 or such that the phi of m is 0? I want to find out the m such that phi of m is 0. Let me know. So now game starts. Beautiful. Now the game really starts. Let us choose m1. I am very clever. We have to be clever. Choose such that phi of m1 is negative. How do you choose the phi of m1 negative? I deliberately choose the m1 such that y of b minus beta, it is less than that. It is not equal. It is, how can it be equal unless you are a god? Your choice cannot be correct all the time. So I deliberately choose a deviation and I go for the undershooting. So that means y of b m1, first value m1, first guess is m1, minus beta is less than 0. So instead of that, I write it as, with your permission, that phi of m1 is negative. So I think I'm deliberately using the structures known as, so this phi of m1 is a number. What is it? Why it is number? This is a number, this is a number. Both are not equal. So hence this is going to be a number. So phi of m1 is negative. Now, first choice I use. Next, I can repeat for the same thing. I deliberately take now m2 such that, see, very clever. Now I take positive. So I put different. As I said, no overshooting, undershooting. I change the angle to this side to that side. So I tell it to go up now. So I put the M2, totally different M1 from M1. I get the structure y of b comma M2 minus beta is positive, which means mathematically I say I have chosen the M2 such that phi of M2 is positive. Well, you have given me two choices. So M1 was chosen such that y of b minus beta is less than 0. That is nothing but pi of M1 is negative. Now I have chosen M2 such that y of b M2 minus beta is positive. That means pi of M2 is positive. Well, then beautiful. So what we have done now, we have chosen the M1, M2 such that phi of M1 is negative, phi of M2 is positive. Immediately a mathematician comes from your whole body. Oh, that means certainly there is a person in the mathematics who can help you. I know at one point it is negative and at one point it is positive. That means the continuous curve must pass through the, and hence I get it as intermediate value theorem says clearly. There exists another point, namely M3, which belongs to these M1 and M2. It's not M1. M1, if it is M1, that would have been okay. Not M1, M2, but in between M1 and M2, there is a point M3. I can assure you, intermediate value theorem says that phi of M3 will be 0. That is actually intermediate value theorem says you have chosen the M1 such that it is negative, chosen the M2 such that it is positive. Between positive and negative values, then certainly is going to be 0. There is an M3 between M1 and M2, and that M3 such that is going to satisfy beautifully. Phi of M3 will be nothing but y of b M3 minus beta is 0. Pakka. There is no doubt about that. That is the mathematical guarantee that it's like fixing the interval. This is called interval bisection method. So I have used the interval, that this is the interval, and I have seen that that point is in between this A and B, or M1 and M2. Now the question is, how do you find this M3? So you only know that the theorem says there is a point M3 in between M1 and M2. How do you find M3? Now again, BTech fellow knows better than most of the teachers sometimes. Sir, if you know M1, M2, then I know, and you are also telling that there is a point in between M3, that between M1 and M2, that is M3, and that is going to satisfy, and they can help you to get the M3. So if you, the question now is, the final choice is going to be mathematically justified, not just guessing. First was guessing, undershooting. Second was guessing, overshooting. Undershooting, overshooting, final choice, third choice must be M3. M3 must be scientifically obtained and justified. Now question is, how do you find this M3? It cannot be guess. Now the best now intermediate value theorem says there exists M3 between M1 and M2. Then immediately our own BTech fellow says, sir, that is known to me. Oh, then what? This is the simplest method. Everybody knows there is a bisection method. Sir, I can find out M3 easiest way. There is no objection. Once you find M3, remember this M3 is not a guess. Though we said the third guess can be correct, it's not guess. Third has to be final. You have to shoot it, the target. M1 was guess, M2 was guess. But guesses are made deliberately, undershooting, overshooting, and the final must be mathematically based so that it shoots the target. Well, you may say, sir, it is not really shooting, it is only approximation. Bisection method, who said it is correct? But therefore, BTech knows that much enough. So this M3 is chosen this way. So if you use the bisection method, this is the M3, and you may not agree with me, but this is M3. There is no doubt about it. We only taught it. So this M3 is going to be phi of M3. Pakka is going to be approximately 0. This M3, that M3 was assured, no? M3 is going to make 0. But the only thing is, we know it is not really 0. Why it is not 0? Because bisection method is not going to give correct M3. Some other method can give you better M3. What will be, there are several other methods. So bisection method is a one option to guess the third one. M1 was choice, undershooting. M2 was choice, overshooting. M3 cannot be choice. It is the final shooting. Based on these two choices, you put the angle and hit, gun, shoot the target. Now, certainly nobody will like the bisection method, but that is the first method. So that means we are now into mathematics. Yes. Then somebody says, sir, I have the regular falsy method. Beautiful. That is better than the regular falsy bisection method. There's no doubt. You can always, if you know better, you find out everything. So there the M3 was given by, let us not quarrel how this method has come. Everybody knows, even it is there in the BTech syllabus. So there is a regular falsy method which can help you to get the M3. And knowingly that this M3 is better than that M3. Because this method gives better than that bisection method. Acceptable. So this M3 is quite reasonable, better than that. Because how do you know this M3? I know all this. What I mean by all this? You know M1, you only have chosen. Phi of M2, already obtained. M2 obtained. Phi of M1, phi of M1, phi of M2. Entire right hand side is known. There's nothing like unknown. Even in the bisection method, simply you know M1, M2, you take the average, that is going to be M3. But coming to the regular falsy, The same story, I know M1, I also know phi of M1, phi of M2, entire right hand side is known, not a big thing. That means you can find out M3. What is the advantage of this M3? This M3 is much better than the previous M3, and that M3 is going to help you to get the phi of M3 is much satisfiable to the 0. What does that mean? That so this y of b M3 is going to be equal to beta. Now certainly you are not going to stop at this place. We want to prove our best possible method, best possible guess, and next is going to be, most of you agree that next you have to go for the next. No options, sir. These two are not really good. So what is the next? That's the best next, according to the logic available in the literature. Newton-Raphson method is the best method to find out the M3 compared to the
For explaining, sir.
just there was a forecut and now joining.
Yeah. Okay, sir. Thank you. Thank you, sir. No audible, sir.
Okay. So
No audible, sir.
okay. Yeah, now we are in the regular falsy method and Newton's Raphson method. Now the drama here is, look at the structure, how we write it. M3 is going to be obtained by this structure. M2, already known to you. Phi of M2, that is known to you. Phi dash M2. This is exactly what we have to teach to the students. See, though we say Newton-Raphson is the best method, now can you obtain M3? What are the right hand side? M2 is known, phi of M2 is known. What is phi dash M2? I don't know what is phi dash M2. I know only phi M1, phi M2, that's all. I don't know what is the phi dash. What do you know phi dash M2? No. Forget about M2. What is the phi dash M? No. Unless you tell me what is phi of M2, phi dash M2, it is not possible to find out this M3 at all. Suppose if somebody helps me to find out the denominator, this is exactly what is the advantage or disadvantage of Newton-Raphson method. Newton-Raphson method requires the function, and bisection method do not require the function. If you know the two values, you can find out. But here Newton-Raphson method demands also you should know the derivative. Here the function is not known and derivative is not known. Who is going to help me? This phi dash M2. And if suppose somebody helps me, let us take Anand helps me, sir, I know what is phi dash M2, then I can find out M3. Now what is the advantage of this M3? 100% guaranteed this M3 is better than those two M2s, and this is going to happen. See, this M, how do I get this phi dash M? Question is, how do I find out the phi dash? Because unless I find out the phi dash, this Newton-Raphson method, unless I write Newton-Raphson method, I start and I badly need the phi dash M1. Phi dash M2, phi dash M. First of all, phi dash M. So how do I go for the phi dash M? Now remember, what was that we wanted? We wanted the solution. Y is the solution of the given problem. Once you say somebody is a solution, what do you mean solution? It satisfies the equation. You put that y dash ym, comma m. I always deliberately carry this tag m. Why carry m? Because of m1 and things. Otherwise, I cannot obtain solution at all. So I want the solution I put inside. See, this is the beautiful, this given problem. Now I put this fellow inside, that is the meaning of solution. When I put it in writing, when I say inside I am, here also x comma m, here also x comma m, and here also. So when you have the problem, when you say solution, that solution must satisfy means it put inside. When you put it inside, this is going to happen. Look at the structure here, this is given one, this is what we have. If y of x is solution, this is the way it looks like. That one is that. Remember, my target is to get phi dash m. Unless you get phi dash m, you cannot find out Newton-Raphson method. Unless you know the function derivative, you cannot use Newton-Raphson method. Now I have decided to find out what is phi dash m. This is phi of m now. So now look at this. This is exactly what I have. I look at this structure. This is exactly when I put the y of xm inside. What I do is cleverly differentiate with respect to m. Where from m has come? M is the fellow who helped you. That m is already there. You have deliberately put inside m. So I differentiate with respect to m. Remember, everything is a function of two derivatives. Now going to the partial derivative. So partial differentiation with respect to m. So look at the first structure. Differentiate this by m to m. And now look at here, capital F. We differentiated with respect to wherever there is a m, I go and do it. No, for this there is a m, for this there is a m. So what chain rule comes? Dou f by dou y and derivative with respect to m for the y. Similarly, dou f by dou y dash and derivative of the y dash with respect to m. So this is going to happen for this equation. The first equation is going to be this equation. And same thing I do for the derivatives also, because these are also involved in the ym. So I differentiate with respect to m, land with the 0. Differentiate with respect to m. Going to be, there is a m here right hand side, you see, differentiation with respect to m. So m, differentiation with respect to m is going to be 1. So I land up here. So now we have, so when I have this equation, given equation is beautiful, probably I spoiled it. Now I have to beautify it, right? So this whole thing, no, I have to put it more dramatic structures, then I put it like this. Let us denote dou y, no, this is equal to d. When I put the z is equal, x is equal to b, and it becomes b. So I introduce a new variable called z. What is a z here? I want to write it as this whole partial derivative. I'm going to denote, instead of writing every time and pronouncing wrongly also sometimes, dou y m, etc. This is going to be replaced by zxm. That's all. If I denote it, then look at it. When I put x is equal to b, then that's all this is going to happen. And also observe that now x is beautiful. As if we're not touching, we're not doing anything with that. Now what I do is a differentiate with respect to that. Dash is going to be differentiated here. So I put it as a y was with x, and because I cannot do now two different, I don't want to write dou y dou x. No, I just use the notation. Z dash is nothing but the derivative with respect to x. Hence, a y as containing the x, so I dash the y dash. This dash means the derivative with respect to x, whereas dou by dou means with respect to m. Now, with this understanding, the entire equation now, this was the equation. Now, I just said you denote z, denote and z dash. This equation now becomes a beautiful equation. This is handled up that in terms of z. Z is going to be determined by because of the. So this condition also automatically, this condition, but in terms of z only. This, so I landed up finding the, where I started with the phi. What is phi dash m? What is phi m first of all? I'm more worried about that only. But I landed with a differential equation involving insularity problem. But the z problem, this insular, as long as there are insularity problems, I am comfortable. So I landed with the insularity problem and got this equation. Once you have insularity problem, now still remember, my target is to find out what is phi dash m. So I got the insularity problem. I solved this insularity problem. I am expert in solving insularity problems. I have no problem in looking at this. So this is interpreted. What is my solution? That is z. It is the equation in z. Z double dash, z dash, etc. So I get the z. What is the advantage of this z? I get b. Once I find out what is z at b, what my z was a notation, and I can find out at any point b, and I land with that's it. This is exactly what I wanted. So I got the z at b is nothing but the dou y by dou m at b comma m. Oh, this is exactly what was that. Remember, I told you that this for notation. Actually, this was a structure. I denoted the phi of m. I know phi. What do you mean by phi of m? Phi of m is nothing but a structured difference between the two numbers. Now, this phi of m is this. Not what I do is nothing but the derivative with respect to m. So I call it, and this is what we want. Z dm. And that is nothing but the phi dash m. So the phi dash m. So phi dash m will come solving this differential equation. This is a differential equation. I solve it and I get the z, I get the phi dash m. So phi dash m, once phi dash m comes, Newton-Raphson method can be used. Once phi dash m comes, Newton-Raphson method is beautiful. So look at the, if you keep on changing, your difficulty will be. But you want accuracy, you should go for the Newton-Raphson method. To find out the Newton-Raphson method, use the Newton-Raphson method, you badly need the phi dash m. Phi dash m is possible. This is how you have to find out the phi dash m. And with this phi dash m, what I go back to that, and I know phi dash m. Once I know phi dash m, I can find out the phi dash at any point. And m is a number. No phi, I can phi dash 2. This will be available. This is available, and this is available. If m is available, so m1 is guess, m2 is a guess, m3 is going to be be obtained by Newton-Raphson method rather than the bisection method and the regular Raphson method. But remember, this is very costly. What do you mean by costly? This is going to be solving a differential equation, again to get the phi dash. And this was done by great mathematicians, to improve, do certain interesting things. Now, this is the most popular integral. Every time we get only integral problems, no boundary problems. Now, if you have the another way of writing, now let us take the second situation. What you have here is, there is a nonlinear problem, but the situation is, you have the, what do you mean by Newman conditions? Derivatives are given. Nowhere the solution is known. Solution is not only in derivatives are known. Hence, it is called Newman conditions. How do you solve this problem? Again, I want it as an integral problem. This is a boundary problem because there are two different points, A and B. Well, I don't like the boundary problem. I convert it as integral problem. What do you mean by that? Now I guessed it. Y of A. The acceleration is given. Velocity was guessed. Now it is Y of A must be, or velocity is given, displacement be guessed. So whether this or that, my mathematics starts same. So what I do now, I guess this M. What is this? Y of A must be guessed. How do I guess the M such that it gives a better solution? How do you say that this is the correct value? You have to satisfy something, to check something, whether you got the right answer or not. What is the correct checking criteria? Now I have to check this, find out or guess M such that Y dash, what do you mean by Y dash? Your missing condition must be satisfied. So this is the condition what needs to be satisfied. So this condition, not Y, it is now Y dash, because what is given? So that only will be guessed. So this is given. The given condition only has to be satisfied. See, he has given two conditions. Only one condition we have used. Second condition, unused condition must be satisfied at the end of the drama. Now the third option conditions, Y dash was guessed. Newman condition, Y was guessed. Now let us take the mixed conditions. Now what happens here? There is a second order equation. Now Y now Y dash is guessed. Only the directly link between them. These called popularly mixed boundary conditions. Now, who can't shoot both? No, and try to avoid that. I'm coming next. How do you choose it? Now, neither Y is known nor Y dash is known. None of them is known. In fact, you have to somehow manage. And of course, I have deliberately taken as minus so that I can do some simplification. So now let us do how do you convert these two conditions as a convertible equations? So what I do is nothing but let me guess only Y dash. As you do it, one guess Y dash. Let us say Y dash is equal to M. And what should be the best case? What is the final case? Now, if I like to put the set this Y dash is equal to M, then my first equation, the first condition can be replaced. This can be M, and then automatically Y of A will come into picture. So the equation becomes so beautiful. So the whole thing is getting converted into two structures. Once I choose M, then I get the first condition Y of A is equal to this much. So I know what is the M, I know what is C1, what you know what is C2, everything is known. So these two conditions. Now this is a problem. By setting this Y dash, you will end up with a beautiful integral structure. Now you solve it. But remember, M was guessed. This M must be checked whether this is right or wrong. There must be some criteria to check whether our guess is right or wrong. Now you have to satisfy the condition. What condition you have to satisfy? The unused condition. What is unused condition? The second one is unused here. C3 Y of B, C4 Y dash B is unused. So that condition is still satisfied. What do you mean that? My M must be such that C3 Y of B plus C4 Y dash B minus beta is equal to 0. The whole thing must be equal to, they are satisfied. So that means, again, denote it as a phi of M. I must choose the M such that this phi of M is equal to 0. Now, again, the same story, you start with M1, overshooting, M2, undershooting, and you whatever the method you comfortable now. I have explained three methods: bisection method, regular Raphson method, Newton-Raphson method, to choose the M1 and M2 and M3 automatically. So then the phi of M will be 0. These are the, now let me go for the third order problem. What do you mean third order? Is the third order derivative, three conditions are given. Again, no quarrel, no fighting with the man. He will give you conditions, whatever he has. So he has Y of A, Y B, Y dash B. Then I want to convert it as, I badly need two conditions for the starting point. I have only one condition. Third order equation badly needs three conditions. Two conditions I have to guess. And we need to guess two initial conditions. These two I cannot use because the other end. I need two more conditions at A. So I deliberately write it as M. Now what about this? I put another symbol, N. I have to choose now M and N. two more conditions for this third order problem. How do I choose these two initial conditions? Because I know only how to solve the initial problems, and it is possible to convert it. Let me take the fourth order equation. The fourth order equation, two conditions are given at A, two conditions are given at B. Deliberately, very cleverly they have given, and improbably he knows the velocity at these both the ends, acceleration at both the ends. So he has given you y of A, y dash A, y of B, y dash B. So some conditions are given. But what I do, if I want to convert it, all conditions must be at one point. At A, two are there, two more are required. What are those two more? Second derivative, third derivative. These two are required. How do I guess it? Well, now let me tell you, this is the most beautiful research area called as, how do you choose these two? Two more conditions are required. This is exactly what we call this, multiple shooting. Multiple shooting means when you go for higher order problems, you need more conditions at the, it's something like having two guns. So far you were enjoying with only one gun and one target. Now you have been given two guns and to shoot both sides. And if you have seen the robo, not one gun, two guns, you have n guns and shoot from each gun the targets. And it is possible mathematically. Because same criteria can be explained to right hand, same criteria can be explained to right, left hand. Both the hands will work independently and you can shoot the targets cleverly. Why only two guns? You can have n guns and shoot. The multiple shooting is the most popular topic and the research concepts. So in higher order problem, what we need to give more guesses, more initial conditions are to be guessed. How do you choose these required conditions? Hence it is called the, not two, more than two is bahu bolte hain, Hindi or Telugu. Ekavachan, bahuvachan. So more than one is multiple, so it's called the multiple shooting methods. So you have more guesses, and to confirm that all guesses are right or wrong, you have a checking criteria, and each guess has to be guessed undershooting, overshooting, and final shooting, and each hand, each gun, each target has to be shot properly. And that's the most popular shooting methods. Now, as I mentioned, all these methods are iterative methods. What are the iterative methods? You have to solve for M1. Only is going to be correct. So maybe somebody says, sir, we are wasting, indirectly you are solving 3 times. Yes, of course. If you want to do it, you solve it. And if you are not comfortable, go to other person. That's all. There is no way. There is a way. In fact, harsh to type that way. If you can't, if you don't like the, who is forcing you to use shooting methods? So, but the concept is simple because the fellow knows only initial problems. He can convert into and justify mathematically. And mathematical justification is excellent, in fact. So, multiple shooting, all these shooting methods are iterative methods. Iterative, not infinite times, not more than 4 times, not more than 3 times. In fact, it is nothing but M1, M2, M3 final. But still, 3 times you have to do it. Now the question comes, can I not reduce? Sir, can you make it as non-iterative? Sir, can you, why did you guess and tell me? So this is exactly what I mentioned at the beginning. See, every method I have generated, I created, a mathematician created, the ingredient structures need not be informed to the user. User need not know the ingredients of the structures. So then you will enjoy. It's like the Rangekutta method. Everybody enjoys because nobody has seen how it is 4th order. If you ask, it takes 4 pages to check whether it is 4th order or not. You get the 4, it gets the answer. That should be the idea. So here, can I now choices? Can you make me non-iterative? That is the real research. Yes, we go for the non-iterative shooting methods. So far iterative because M1, M2, M3, 3 times many. You have to guess y. Difference between the Dirichlet and Newman. In Dirichlet, you get y. You have to guess y dash. In Newman, you are given y dash. You guess y. So now I guess this. And these are the guesses. No m is known to you. These are the guesses. These guesses are based on the solving and confirming. These are the one can easily prove that these are the only choices, the best answers. If alpha is equal to 0, these are the choices. Y of A. Now, sir, this is nothing but solving that problem. What do you mean by in iterative? What were we doing for M1 once, M2 once, finally for M3 once. That means totally 3 times you are solving. But here also you are indirectly solving 3 equations, 3 unknown, 3 are. So not much is saved. This is exactly how you do research. So what we wanted was a non-iterative. We expected only once, but 3 equations. Oh, this is as good and as bad as what we were doing in the iterative methods. Iterative methods, what we were doing for M1 solve once again, for M2 solve once again, M3 solving once again. Indirectly speaking, you are solving 3 times. But here, solving once only, but 3 equations. Oh, not much is saved, not much. Only thing is, choices are now fixed by the teacher or some god or some godly man or god man. So you have no business in guessing now. There the business was guessing. You only remove the guessing, but dictating, but the conditions are beautiful, but the equations are same. Now question comes, sir, can you reduce it? Otherwise, there is no advantage in writing it as a non-iterative. It is as good as doing the same thing. 3 times you are doing there. Now you are 3 at a time once you are doing it. So logically speaking, not much is saved. But spirit was saved. Now let us go for the new. So now let me take the non-iterative as for the mixed boundary conditions also. Mixed boundary conditions also, it will be same. I will give you 3 equations, solving this 3, then 3 conditions are there. So again, the conditions are guessed. All conditions are guessed. These are based on the experiences. And so this is the literature available in the most of the good books. So if you want non-iterative shooting methods, these are the equations, these are the proved by iterative structures. Now we want to reduce, instead of having 3 equations, we are going to final few seconds. But we don't want 3 equations, really not satisfied, because 3 times doing one time, but 3 things is equal. So not much psychological happiness is doing all at a time. That is the only advantage. Previously, for M1 do one time, for M2 one time, M3 one time, 3 times you are doing. Here, one time only, but 3 equations. That is the advantage of called non-iterative. Oh, I already given you a hint. The Y3 came because complementary function plus particular integral. Particular integral is one structure. There can be 2 structures in that. It's one part only. Complementary function certainly will contain 2 linearly independent structures because it is second order C1 phi 1 plus C2 phi 2. Oh, that was the hint for me to develop the non-iterative structures, hence I could get the 3 equations. Now, frankly speaking, for a BTech fellow, sir, don't confuse me, sir. I have only 2 structures. What do you mean 2 structures? Complementary function, particular integral. So you should have given me only 2 equations. Yes, I will give 2 equations. Don't doubt me. We have tested. It is now going to be this. So I have the equations. 2 equations. So these are the equations. These are the 2 equations. How these 2 equations comes into picture. So we developed these structures and then 2 equations came into picture. These are the 2 equations, y1 and y2. So now reduced. Previously y0, y1, y2. Now we have only y1, y2. This is the structure we have. Now look at the combination. There I have written only simply y0 plus y1 plus y2. Now you have some combination, a beautiful combination, lambda, the coefficient of y1 and 1 minus lambda, 1 minus lambda, convex combination. These are all mathematically known popular structures. This is the best combination we tried. And if you substitute, if you think the solution has this combination, and I can find out the y1 and y2 solving these 2 equations. These 2 equations, you need not guess anything. Already conditions are given, and I am giving dictating terms. These are the conditions to be guessed. No, you don't have to guess anything. I am giving you these 2 equations will give you the solution y of x. So for a given differential equation, these 2 are. So if the Newman conditions are given, again the conditions are different. So they are available in the best book. So if you want beautiful, based on the conditions, whether you have Dirichlet condition, Newman condition, or mixed condition, based on that, equations will be different. So keep asking the questions, then this will be answering by this, what sort of conditions we have. If there are mixed conditions, the structure is same. What do you mean structure? Y of x is assumed as a combination of these 2, combination of this. So y1 and y2, lambda into y1 plus 1 minus lambda into y2. So is a mixed condition or Dirichlet condition? Dirichlet condition same, heading only getting changed. Structure remains same, but equations get changed. Equations remain same, but the conditions get changed. So this is the drama going on. So tell me the condition, give you the answers. So mixed conditions, we have this. So but this is the non-iterative new structure. We have only 2 equations to be solved, and this is the most popular method, latest method everybody is using. If we have a linear boundary problem with the Dirichlet conditions, you have the two equations only, Newman conditions, two equations only, mixed conditions, two equations only. All these are popularly justified and people are using it. And an advantage of having the, you can, once you convert into problems, you can solve these two equations again. So the best book is the Shooting Methods by Roberts, S.M. Roberts and Shipman. This is a book, title is called Shooting Methods. He has even all the justification for all these methods and making it as iterative, non-iterative, and continuation of the methods. I have explained only for the second order equations. You can go for third order, fourth order, any order in fact. So the concept of converting into boundary problem to integral problem, iterative, but that can be made it as non-iterative, but the number of equations will remain same, but you can reduce the number of equations by assuming the solution as complementary function plus particular integral. By default definition, if I can think of the solution as complementary function and particular integral, there is a spirit. That means that's, see, the structure is you want to think something already known. Oh, it should all be like this, should be like that, it should be like that. So we have eliminated guessing. Because sometimes guessing by unknowing person will be very bad. No, see, I mentioned if you know the velocity, engineer will tell you what could be the acceleration at that point. But if you give it to a blind mathematician, a so-called typical mathematician, he will simply put it at 0. Because he has to choose. See, putting 0 is inhuman. If you have to guess it, you don't guess it as a killing person. 0 means killing. So engineer, no, sir, it cannot be 0, sir. Then there is acceleration. When there is a velocity, sir, it cannot be 0. So mathematicians say, oh, okay, put 0, you get something. Put non-0, you get something. That is the hit and trial. No. When you have to choose it properly. When you delete the choice of this itself, then becomes a non-iterative. So here in the last 3 slides, what we have done is we don't give any option to the problem solver. We say, solve this, you get that. So you have the P1, PQRS. So you give me the equation. I will help you to solve these equations. These are the 2 integral problems can be solved by any Runge-Kutta method. I'm not advocating Runge-Kutta method because that is known to all the students in the world. World knows, given integral problem, fellow knows how to solve it. Fantastic, one simple right. Advantage is that no matrix, no structures, simply put H is equal to something and you keep on getting the answers. And people are comfortable. And this is the best method available. Nobody can forget it. And the concept of solving boundary problem becomes easy. And that is how the people are using, knowingly or unknowingly. Engineers like it. Mathematicians may not like it, but engineers see ultimately a method becomes popular if the users are there. If there is no user, maybe sometimes we also don't use it, then what is the point in giving method? These methods have become very popular. Almost all researchers, mainly in the modeling techniques, especially engineers, they really use these shooting techniques. Whatever is missing that can be guessed. Our guessing must be mathematically justified. If justification is given, people will appreciate it. So these are the 3 things. We call it as a non-iterative, 2 equations only. But the only thing is, if somebody wants the details, sir, how did you choose these? No, I have not chosen. There is a person by name, the book, Shooting Methods by Roberts and Shipman, based on the experience, based on the, solving several things. They have given these are the conditions to be taken for the given with the Dirichlet conditions, Newman conditions, or mixed conditions. This is going to help you solving the boundary problem by shooting methods. So shooting method is not a method, it is an approach to convert to boundary problem to integral problems. I think with these few remarks, I can now say thank you all. And any suggestion, comment, or any discussion can be emailed. That is easiest way, so that you get convinced. I get convinced and satisfied by writing, or you can pose me right now if you have any clarity or if you have any questions. I'll go back to my video now. Okay, Anand.
Thank you, sir.
Yeah.
Thank you for enlightening a topic, and all the participants are giving their valuable feedback, sir. Shall we take question and answer, sir?
Yeah, sure.
With your permission, sir.
Yeah, please.
Dear participants, you can raise your questions to the Professor Y.N.Reddy, sir. Please unmute your audio. Please ask the questions to directly, sir. If anybody. Dear participants, you can ask your questions to directly Professor Y.N.Reddy, sir, by unmute your audio.
Yeah, madam.
Good morning, sir. This is
Good
Pooja.
morning. Yeah.
Sir, my question is that if the boundary conditions are weak, then only can apply this shooting method, or some strong condition should be there.
No, it's nothing to do with the weak or strong. The only problem is if you want to solve it as a boundary value problem, the question comes matrices. To avoid the matrix phenomena, we go for the initial methods. And boundary conditions, weak or strong, you have to satisfy. Am I right?
Okay.
What are the conditions are
Okay.
given? See, you have no, see, I'm a mathematician. I don't know whether you are a mathematician. See, mathematician was given by an engineer. He says these three conditions should be satisfied. So how whether that equation is good for him, a condition is given by him based on experience or whatever he wants, you have to satisfy. No? So preferably, our job is to satisfy the boundary condition. That is the solution which satisfies all the boundary conditions. So it is independent of whether it is weak or strong.
Okay, sir. Thank you. Thank you very much, sir.
Okay, Anand, then
Next person, anybody?
you can ask.
Sir, I am giving chance to the thank you for giving opportunity to ask a question, sir. If no one is taking questions, we can conclude, sir, because most of the participants are in their chat box. They given their feedback by
Good.
giving excellent sessions. So we once again thank you, sir, sparing your valuable time with us. We take your blessings to conclude the today's session. Before closing, Dr. Shivashankar sir speak words with you, sir.
Yo, welcome, Shiva, my pet students.
Sir, we are,
All are my pet students. All are my pet students. I'm proud of all of you.
sir, we are very much thankful to you, sir. As a resource person in this FDP, it is added a lot of value, sir. And all the participants given their excellent feedback. I am very much thankful to you, sir. Thank you, sir.
Thank you. Thank you.
Hello, can I talk to Anand, sir, please?
Yeah, please carry on.
Sir, my name is Pooja Girotra. I haven't able to join any of FDP group, either from Telegram or from this WhatsApp group.
What? Okay.
So kindly add me, or you can send me daily invitation in my mailbox as per your convenience, sir. Means I just want to attend this FDP wholeheartedly.
Yeah. We'll do it in your favor, madam. We'll do
Most
it.
Thank you,
welcome.
sir.
Welcome.
Thank you.
Thank you.
Sir, I am Purnima. I wanted to talk a few minutes.
Questions?
No, sir. Because a lot of people are working with shooting method, me too also working in shooting method only. So a little bit clearance I got after listening to your lecture. It's very much useful for me in particular.
Thank you. Thank you so much.
Thank you very much, sir. Sir, a little one more request from my side to Anand, sir. Sir, me too joined this FTP, but I couldn't join any of the WhatsApp app, whatever you have given the link. I'm unable to join in that. Kindly send me the link also. Morning I asked my friend and then only I joined the session. It was too late actually, and I joined.
That will take care, madam. Regarding the topic.
Okay, madam.
sir, okay. Thank you, sir.
Okay.
Thank you very much.
Thank you, madam.
Anand, can I leave now?
Yeah, thank you, sir. Thank you for sparing with us, and with your blessings, we can conclude. Thank you, sir.
I thank
Thank you,
Shiva.
sir. Thank you, sir.
Shiva, Raj-Reddy, Ramesh, all are my pet students. Anand, you are, of course, certainly you are my student. All are my students. Convey my regards.
Thank you, sir.
Convey my regards to Ashok Reddy once again.
Thank you, sir. Participants, you can ask your doubts. One thing we can say that out of all the participants who joined in our groups, we try to convey the message. If anybody missed out, that we'll take care. Today the first day, therefore we are busy with arranging all the things. So somewhere else missed out, we will do it and we will justify for your FDP for joining this program. And we thank you one and all. Feedback link is also posted in your chat box. I request all the participants for the next day, please kindly mute your audio and video. It gives little bit trouble. Otherwise, it gives a problem to the speaker also. So with these words, we conclude you first day of session, and tomorrow the same second day links will be posted in your respective groups